sets, just the basic computations there. And then we have sequences and series, finance, growth, and decay. We have functions, which is the most part of this paper. And then we have differential calculus. The last topic here is probability. And then when it comes to paper 2, the main topic is Euclidean geometry, and then followed by trigonometry, I believe. I think in that order, then followed by analytical geometry. The last topic, and which has the least marks, is statistics. So the most marks are with Euclidean geometry. So we're gonna start off today, like I said, with the nature of roots. And then what I mean when we talk about roots is answers. We're talking about answers. When you have that equation, when you have that equation of x squared, maybe minus 2x minus 3, and then the z is equals to 0. And then you'll then use this equation, put it on the quadratic formula to find answers, to find solutions, and simply to find roots. So solutions and roots is about the same thing. Here what we talk about, or what we want to talk about, is the nature of those solutions, is the nature of those answers, or is the nature of those roots. So what we'll normally have from this formula or from the equation is a, b, and c. So a being the 1 in front there, b being the minus 2, and then c being the minus 3. So that's how these numbers go. And then what we'll do, so this is just an example that I'll quickly go over here. So our a is 3, our b is positive 2, our c is negative 4. And then we'll take these and put them in the quadratic formula. And then when we put them in the quadratic formula, we'll then punch our calculator to find answers. So yeah, to find answers. And then maybe let's say, just for the sake of time, the answer is 1 and the answer is 2. So these will be the answers. The nature of these answers is that they are real and they are positive. Yeah, we'll just look into that. They are different. There's 2 of them. We'll look into that. So the things that I've just mentioned now is what we refer to when we talk about the nature of roots, but it is explained in detail over here. Okay, so inside the quadratic formula, we have b squared minus 4ac. So that is under a square root. So this, we prefer it to be always positive, or to be always greater than 0, meaning the same thing, it's positive. So we call it the discriminant, and we prefer that it is positive. And then sometimes it is 0, and then sometimes it is less than 0, in which case it will be negative, less than 0, in which case it will be negative. So how do we then describe all of these cases? Okay, the first thing we want to do, every time we have a formula, we have an equation, we want to know what the discriminant is, the small triangle. We want to know what that is by looking into the equation that is given. So in this case, it's 3x squared plus 2x minus 4. We have already identified our a, b, and c, and we want to then put that a, b, and c into the discriminant formula. And then in this case, what we're going to end up with is, okay, let me just write it here. We're going to end up with 4 plus 4 times 4 is equal to 16. 16 times 3, 16 times 2 is 32, plus 10 is equals to 36, 38, plus 6 is equals to 40, 44. I want to believe this is 44. And then with that, we're going to be having 48 as a total. So this 48 will then give us further information. Okay, yeah, so this is 12 times 4 should be 48. Yeah, so this number will give us further information on the nature of the roots. So here we're not really finding the roots themselves, or we're not really finding the solutions to the equation, but we're finding the nature, how those solutions look like. Okay, and here's the interpretation. So when we get that the discriminant is less than 0, we go with this branch. It means that there is no real roots. There is no real roots. That's the comment that we make when the discriminant is less than 0. But if the discriminant is greater or equals to 0, then we have real roots. We call the branch of having real roots. And then when we have that the discriminant is not only greater or equals to, it's actually greater than 0, we go with this option. So it is greater than 0, we go with this option. When it is exactly equals to 0, what it means is that there is 2 equal roots. There is 2 equal roots. These roots are real. So we have already established from here that the roots are real, and then when we go down, there is 2 of them that are the same. And these cases is when you have you have one x-intercept there. It's actually 2, but in the same place. So another one is this one, where you touch the x-axis at one point. You touch it with the parabola at one point. So you have just one root, but we say it's 2 equal real roots. But when we have that the discriminant is greater than 0, then you're going to have 2 unequal roots. So So it's going to be two unequal root. That's when the discriminant is greater than 0. That is this case. You'll have that root there, you'll have that root there, that root there, that root there. And another definition for roots is the x-intercept, the solutions, and the zeros of the quadratic equation. So you take a quadratic equation, you equate it to 0, and then the roots will be the solutions to that equation. Okay, fine. And now we know that, okay, the other option is two unequal roots, the other one is two equal roots, in which case we just mean that we have one x-intercept. Okay, here we further branch into having a perfect square. If the discriminant is a perfect square, meaning the discriminant is either 1, 4, 1, 4, 9, and then we have 16, we have 25, you know, these type of numbers, 25, and then you have 36, 49, and then you continue. So if you find that the discriminant is any of these numbers, it means that the roots that you're finding are rational roots. The roots that you're finding are rational roots. And then rational roots are roots that you can write it as fraction. Maybe, for example, 2. You can write 2 as 2 over 1. It is a rational root. Or you can write 3 as 3 over 1. It's a rational. It's more of a whole number. But when you find that the discriminant is not a perfect number, maybe the discriminant is 5, and 5 is not a perfect square number, because the perfect square numbers is the ones we've listed here. They continue to 49, 64. You can just check them. 81. Also have 100, and then they continue like that. So, but when you have something like 5, the discriminant is equals to 5, you have irrational roots. So it's two irrational roots. So irrational roots is numbers like, let me say, 0.0293. Just as an example. See, this is just a decimal. It is not a rational root. Nonetheless, it is a root. So here's the comment that we make when we're given a situation. We find a discriminant, we decide whether it's negative or positive. If it's negative, then we don't have real roots. That's the comment we make. We first say the discriminant is negative, or we just say the discriminant is less than 0. It means there's no real roots. But if the discriminant is greater than 0, it means there's real roots. It is greater or equals to 0. There's real roots. So we're going to say discriminant is greater or equals to 0, and then we say it means real roots. Then the next comment is on whether the discriminant is equals to 0 or greater than 0. If it is equals to 0, the next comment we say it is 2 equal real roots. And then when it is greater than 0 and not equals to 0, the next comment will be 2 equal roots. So it's 2 unequal real roots in this case. And then we still go down. If the discriminant is a perfect number, so it means that we have 2 unequal real and rational roots. If the discriminant is not a perfect square, it means that we have a real root, that is, we have two unequal real roots that are irrational. So that's it. That's all the comment that we make with this thing. And then I'm just gonna have one example, and then yeah, just not to further track this video. So this is a table that does those explanations very well. But okay, maybe we can work with this example, the one that is here. Okay, so we have x squared plus x is 1. So our a is 1 there, a is 1, our b is 1, our c is 1. So it's just ones, and then we put that into the discriminant. So you have b squared, you have minus 4, a and c, and then this will give you 1 minus 4, which is minus 3. Here we know that if it's minus 3, it means the discriminant is negative. The discriminant is negative. What does that mean? Is that we do not have real roots, or the roots, they are non-real. We don't have real roots. And then the graphs of this situation will look something like this. So they don't touch the x-axis. They avoid the x-axis. They start down or above the x-axis. Okay. Second example. You have your 1 there. You have your minus 6. You have your 9. You put that into the discriminant. Minus 6. 1 there, 9 there. We find that this gives you a 0. So when the discriminant is 0, we know that it is real because it is greater or equals to 0. So it being equals to 0 means that it is positive in a way, or it is greater or equals to 0. So it is real, it is rational, because 0 is considered a perfect square. Yeah, but we don't really look much into that. And then the roots are equal. So you have 2 equal roots, but it will seem that you have just 1. Yeah, so there's a 1 and it's 2 of the same. So that's when the x-intercept will be just at 1 point, touching the x-axis at 1 point. Okay, and then the other situation is when you have okay, you have your A, your B, and your C. Put them in the discriminant, you get 49. 49 is a perfect square number because you can put a square root there and get 7. It's the perfect square number. And then the discriminant is greater than 0. That's the first thing. Discriminant is greater than 0. It means that this is a real root. There's 2 unequal real roots. Actually, they mentioned that here, these roots are unequal. These roots are rational because we are getting a perfect square number, which is 49. And then, yeah, they're rational and they're unequal. And then the graph will look something like that. Also, with the case where the roots is you are getting a number greater than 0, but the roots are not perfect, we say they are irrational. I mean, the number is not a perfect square. We say they're irrational, and then they are still unequal because there's 2 different ones, and then they are real. So that's all about the nature of roots. And then I will see you on the next video that I make. Then on the next video, we'll be looking into sequences and series. I'm deliberately skipping these ones with the aim of coming back to them. Thank you for tuning in.